Axis Engineering plc, a name synonymous with quality, has established an unshakable reputation as a leading general contractor in the local construction industry. Axis Engineering's piling division has, for over a decade, catered to business partners' needs for deep foundation solutions. The piling division leverages the company's expertise and culture of excellence to provide vital specialized services to those who have come to trust and rely on Axis. Board cast in situ piling is the most widely used technique where deep foundations are necessary. It has the advantage of being viable in any type of soil and is a feasible solution for high-rise buildings which require deep foundations. This technique requires a firm platform. If the area to be worked on is not firm, the ground must be prepared before the piling operation proceeds. The piling process begins with the setting out of the exact position of the pile in the ground using high-caliber survey equipment such as total stations. The boring rig is then moved to that exact location and its horizontal and vertical stability are ensured. Drilling is carried out, and the sides of the bore are secured with a temporary metal casing of a depth varying from 3 to 6 meters. Following the insertion of the casing, boring resumes and a bentonite slurry is prepared and pumped through a hose concurrently with the digging, so as to stabilize the soil. The process continues until the sound rock level is reached. At this juncture, which is a hole point, the depth is measured. The method of identification of a hole point are comparison with a borehole log, inspection of rock samples, and monitoring of the penetration rate. At hole points, examination and agreement is required from all parties. On confirmation of sound rock, rock auger and rock barrels are used for the rock socketing procedure. The final depth measured using a measuring tape is another hole point. Once the boring is completed, the desanding process starts and the bentonite slurry is circulated through the desander until its sand content is within the required range. The bentonite is tested to ensure that its density, viscosity, sand content, and pH value fall within the requisite ranges. With the sand removed, a suction pump is lowered to the bottom of the drill hole to further clear debris from the bottom. A rebar cage designed to reinforce the pile is fabricated on site to conform to the borehole depth and is lowered into the hole by way of a crane. In order to do the underwater concreting, a special funnel system called a trimmy pipe is inserted into the borehole, and the concrete is poured into the pile shaft. Before the concrete hardens, the temporary casing which was initially installed is extracted. The entire procedure is carried out under a strict quality control process which is well documented. The concrete at the top part of the shaft, which is contaminated with debris, will be cut off later using a jackhammer in a process known as head cutting. Piles are then further tested to ensure they are suitable for taking the desired load using various tests designed for this purpose. A wave is introduced into the pile using a rubber hammer to detect potential defects such as cracks, voids, or soil inclusion in the pile integrity test or PIT. Quality and consistency is tested using cross-hole sonic logging or CSL, a modern technique where the full stem of the pile is scanned with a high-frequency signal for a thorough examination both lengthwise and across the pile. A PDA or Pile Dynamic Analyzer ascertains that load-bearing capacity of the pile meets specifications, checking also for the capacity to bear impact. The company's testing and quality control mechanisms assure its many long-term business partners not only of the commitment to meeting specification and regulatory requirements, but to building a strong foundation for a better living and work environment. Results are key to access. Technically competent staff who bring years of experience and professionalism to every project. This, in addition to Access Piling's modern, constantly maintained and updated fleet of machinery, the use of concrete from the organization's own concrete batching plant, the intervention of the in-house design team to ensure structural stability, casing fabrication by the fabrication division, and the supply of equipment by the equipment division creates undeniable synergies. One of these is the unique project management outlook that would not be present when aspects are subcontracted. The result is timely, efficient delivery with consistent quality and care for the safety of the contractors, the end users, and the environment. Instances of this are evident in the leading high-rise hotel development in Colombo. Scale is taken in stride with the backing of the company's ample resources, as was exemplified in the efficient completion of the biggest piling contract in Sri Lanka, consisting of 1,700 piles, the Kaduwela-Kadavatha section of the outer circular highway. The ability to handle projects of such stature is testament to the fact that for nearly 15 years, Access Engineering PLC's piling division has been preparing sites for buildings for private and government sector, as well as infrastructure for cities such as bridges, high-rise buildings, and water treatment plants, paving the way for a metropolitan future. Access Piling, a strong foundation for future development.